Video is just kind of go through a little bit of what you've been learning about experiments and statistics, review it kind of in a quicker pace because you have been looking at all of these things, and just try to help you make sure you got all these words down and you understand the differences where there's, words that are so close together. And we're going to start with descriptive studies versus descriptive statistics. These are so close together. So a descriptive study, remember we talked about these as being observational studies, case studies, right, where we're just describing what we see. And they can use descriptive statistics, and so can a correlational study can use descriptive statistics, and a experimental design can use descriptive statistics. So let's talk about those things. Descriptive statistics can be quantitative, right? They can be quantitative, meaning numbers. And what are the big ways we can do this? We can do this with how things are the same, right? The mean, median, mode. Quartiles we use. Sometimes quartiles is just dividing everything up into fourths. So showing the smallest fourth, the middle fourths, and the biggest fourth, right? The mean is the statistical average. The median is the exact middle data point. The mode is the most occurring data point. Right? And so we have measures, we call these measures of central tendency. How are we talking about the middle of the data? And you learned this week about how do you talk about the dispersion, or how spread out the data is. All right, and I'm going to bring this up just for a second. If I look at this graph down here of men, women, and NBA players, right? These are all roughly normal curves. We're going to talk about that, and I'll bring it up more in a minute. And when we talk about these curves, the middle, mean, median, and mode, right? When it is a symmetrical curve, the mean, median, and mode is in the middle, right? And how wide it is the dispersion, right? So women have the lowest standard deviation here. We don't know exactly what it is, but we know that there's less dispersion or less spread out data in women, and men has a little bit more, and NBA player surprisingly has the most dispersion. All right, so when we're talking about descriptive statistics, we can do this with quantitative, when we do this with numbers, and we can do it with the numbers themselves, or, and I have here's a whole bunch of, right, the mean and the standard deviation and a whole bunch of variables. This actually comes from a correlational design, right? They're looking at looking at data, but they're still giving you the descriptive statistics. So it doesn't have to be a descriptive study to use descriptive statistics. I can also describe what I see in graphs, all right? This one is effects of social media on life, feeling happy, feeling unhappy, or both, right? It's just summarizing the data. We can describe statistics with numbers or graphs. Right? But it doesn't have to just be a descriptive study to use descriptive statistics. We can also describe data, and this is more often in a descriptive study, qualitatively. Qualitatively is reporting how many people kind of talked about, I just don't like social media, right? Right? Or this is just describing what we see in words. So qualitative with words, quantitative with numbers. Right? And we can have a descriptive study that uses descriptive statistics. We can have a correlational study that uses descriptive statistics. We can have an experiment that uses it. Right? And one way we summarize quantitative data is by using what's called a histogram. This blue here we have and you always start to look on the x-axis, I have hours spent on social media, and on the y-axis I have count. So this looks like 58,000 teens spend between 0, if this is 2, this has to be like maybe 30 minutes, 60 minutes, 90 minutes, about, right? So how much time, how many hours they're spending on social media. This is what we would call a positive skewed data, because the mean is being pulled out by these people who are using it a lot. All right, so in a positive skew, the big numbers are pooling the mean. The mode is going to stay with the most occurring. The median is going to get pulled not so much, and the mean is going to be pulled a lot by the data. So A histogram just takes and it's like a bucket, right? Between 0 and this value, how many people fit in that bucket? I can take a histogram and I can just smooth it out. This could be placed right over this. I could smooth out this curve, and then I call it a distribution. And the people fitting under this curve are the people fitting in these buckets, but we don't see the buckets so clearly. And we have 3 distributions you learned about this week: positive, negative, and symmetrical. And you need to know which is bigger, the mean, median, or mode in positive and negative, and know that in symmetrical, they're all the same. Another interesting thing happens with a normal distribution is no matter how spread out the data is, no matter what the standard deviation is, if it's a normal curve, then between less than the, so here's the mean, and if we go 1 standard deviation less than the mean and 1 standard deviation more than the mean, the same percentage of people are fitting in those. Same thing, if I go 2 standard deviations away in both directions, I have the same number of percentage of people falling into those buckets or categories. All right, so now we want to talk about, we had this term descriptive statistics, and we're contrasting that with inferential statistics. So when I have inferential statistics, I have my population, I've taken a sample, I can describe that sample, right? And if I want to take this sample and talk back about this population, then I'm using inferential statistics. That's the most basic part of the term, is I want to generalize from my sample back to my population. And when we're doing that with an experiment, we're then taking that sample and we're dividing it into 2 groups, an experimental group and a control group. What makes your inferential statistics kind of better? Right? When our sample, this is a representative sample or a random sample, when this sample is not biased, right? If I had a population and I said my population was all teenagers and my sample was all girls, right? That is not going to represent my population, and my statistics are not going to be very good at coming back to talk about the population. Also, when I take more people in my sample from the population, that makes it better. And when I have multiple samples, when I don't just do something once and I look for consistent results, that means my inferential statistics are going to be better. All right, in this discussion, you're really focusing on what does it mean to be statistically significant. So we have these 2 groups. We have this experimental group and we have this control group. And we're going to find the mean of many different things when we do this here, right? We could find, it depends on what we're trying to measure, right? Let's say that you were trying to measure, I have a little study here. This one is showing, this one has 3 groups. So in one group, they got to have their phone with them, that's the possessed. So their phone was with them and it was turned on. There was 44 of those people. The average positive emotional change as measured by a survey was 1.89. The standard deviation was 4.7. Another group had the phone on them. It was turned off, right? The positive difference in their emotion, all right, and the standard deviation. And another group, 54, had their phone taken away from them completely, and what was their, here was the positive difference in their emotion, and here's the standard deviation. If I turn this into histograms, we would see that these are really rather close to each other. So the question is, and this is, you don't have to know how the statistical test is done, but there's a test to say, are these histograms different enough? Are these groups different enough to be caused by this condition, right? Do you get an emotional change based on whether your phone is with you and on, with you and off, or not with you at all? Does that cause a change in your emotion? And we would need a test to tell us whether this difference is big enough to have been caused by my condition, or could it have just been caused by chance? And that's what statistical significance, that's all it's telling us. How likely were we to get these differences in these groups just because of chance alone? All right, now there's a lot of confusion between when am I doing correlational research and when am I doing an experiment. And partially the question is correlational research just descriptive, or is it also inferential? And correlational research is descriptive if all I'm doing is taking a sample, asking them questions, right? I'm going to get rid of this. I'm going to keep depression here. I'm going to put the variable of phone use, all right? So back to that kind of, we had this up here, right? Hours spent on, oh no, that's just count. We want to do how much time they're on their phone and how depressed they are. What makes this descriptive is if I take my population of teenage girls and I sample them. And if I look, I'm just going to start getting data points. So each one of these dots is a data point. All right, so I get a data point. So how much phone use girl number 1 uses, her rate of depression. So we're going to actually say we want to see, we're going to think there's a negative correlation here, right? So right, and then I have, oops, I just want to move this dot. I have another girl here. These are each data point is somebody in my sample. And I'm not manipulating anything. All I did was ask my sample of girls to tell me how depressed they were and tell me how much phone use. I manipulated nada, right? Nothing has changed. All right, now let's say, so this is correlational research and it's descriptive. I'm not saying anything back about all girls. I'm just telling you about the girls in my sample. Now, I might want to, I might say, does this represent my population? And maybe I do a whole bunch of samples and see if I find something the same, right? It's still correlational research and it can be inferential. Now, what's the difference between this and doing an experiment? Because I might still use a scatter plot and look at a correlation with an experiment. The difference is, in an experiment, I would be manipulating phone use. All right, I would be saying, you're assigned to group 1, you don't have your phone, you don't get to use it at all, and you're assigned to group 2. And I probably can't do this after people are really used to their phones, because that may change the whole dynamic. So maybe I take a group of young ladies in a country that has no cell phones, and I give one group, random sample group, a phone, and I don't give the other group a phone, and I see what happens to their change in depression. Right? Just ignore this part of the slide. I'm using it for something else. All right, so when we look at having a research design, we might still look for a correlation, but we're manipulating this independent variable. We're not just measuring what already exists. All right, last, let's just do this together. So let's check our understanding. Sampling from the population, right? Is that correlational or experimental or both? Both, right? I got a sample. Research question, both. I'm going to have it in a correlational design and an experimental design. Hypothesis? Could be in both, right? Descriptive statistics can have those in both. Correlational coefficient? More likely in a correlational study, but I could look for this in an experiment. I just have a manipulation of variables. Okay, so I'm going to kind of, can I duplicate this, copy this? I copied the dot. I want to copy the whole box, because this can be in both, but if it's an experimental, I must manipulate the variables, because I have a control group and I have an experimental group. I have random assignment. I'm going to have a placebo. Scatter plot, most likely correlational. Could I include it in an experiment? Yes, I could. Use inferential stats to see if two groups are significantly different. Yes, this has to go in this box. All right, so I hope that helps you clear up a little bit on making sure you can identify descriptive research, correlational research, and a true experiment, helping you understand that descriptive studies only use descriptive statistics, but descriptive statistics can also be used in correlational research and experiments. I hope you feel a little bit more confident in reading histograms and normal distributions. I hope you're feeling better about knowing when something is inferential statistics. And lastly, that you understand statistically significant is when am I trying to find out if these groups are different because they're just different by chance, or if they're different because of my independent variable.